Hi everyone, this is Aruna Richami, Assistant Professor, Department of Information Technology, SNS College of Technology. In this lecture series today, we're going to see about the detailed explanation of the schedule. So schedule definition I have already discussed in my previous video. Kindly watch that video before coming over here. So according to the schedule, it is nothing but the sequence of execution in a certain order. So in which how the transaction to be executed, that can be defined under the schedule. Here only it will have a two state. One is the successful completion state, another one is a partial completion state. If it is successfully completed, definitely you have to execute the commit command. If it is not successfully completed, definitely you have to execute the abort command. These are the two important commands can be used under the scheduling concept. So first, for example, we're going to see my schedule one. So what is my statement? I'm having a two transaction T1 and T2. So here I have to define the thing, the T1. We're going to transfer $50 from account A to B. Again, my transaction 2 is 10% of the balance from A to B. I'm going to transfer. One first cases, I'm going to transfer 50 rupees from A to B. In my second transaction, I'm going to take 50% of my balance of my A account to that particular amount to the B. So here it can be called it as a serial schedule. Why I am saying it is a serial schedule means T1 followed by T2. First the T1 instruction to be executed. After that only your T2 transaction must be executed. Is it clear? Yes. So the collective only we can call it as a schedule one. So this only I'm going to represent it over here. First we're going to read A. In A, we're going to debit the amount 50 rupees. Going to write an A. Again, I'm going to read my B. That debited amount here, I'm going to add it over here. Write the result to the data item. Finally, it is a committed. If it is encounter the commit, we know that transaction T1 is completed. Then we can move to transaction T2. In your transaction T2, the available balance, in that we're going to take the 10%, that particular amount we're going to transmit it from A to B. First, we have to calculate the how much the 10% of my balance. For that, we're going to read A. In A, I'm going to take the 10% amount. So that I'm going to update it in my A. So I'm going to write the result A. After that, I'm going to read B. In the read B, whatever the debited amount here, it can be credited. It will write the result B. It will encounter the commit. So through that, if it is a commit is encountered over here, so definitely successfully we can say that my T1 transaction and T2 transaction is successfully committed. If you see through that, it is doesn't executed over here. Here I have to, again I have to do the abort. Abort means my data item A, what is the initial value, that must be redo and it can be updated the data item of A. So this particular concept only we can call it as a serial schedule. This is another example for serial schedule. Here T2 for the same transaction. This one. So here we are saying only I have little bit change T2 first, it can be executed. The next T1. This is also, we can call it as a serial schedule. The same example. Here also it will encounter the commit. It shows that my 100% my transaction is completed. Third thing. So these are the not a serial schedule. Why I'm saying it is a not a serial schedule? Here, it doesn't notify any commit command. So it is partially executed. It will leave the resource for the transaction T2. Again, it will leave the resource. It is also not completed. Again, it will leave the resource for T1 to complete the thing. In this case, only committed. You're having certain delay period. See through that. So these also we can call it as a schedule, but it is not a serial schedule. It is equivalent to schedule 1, but it is not a serial. Why I'm saying it is not a serial schedule? There is no any continuous pro. It will preemit. It's not a non-preem. It will preemit over here. It will leave the resource for the another transaction to be executed. After certain the thing, your B transaction can be updated. Whether it is a consistent state? No, definitely it is not a consistent database. See here, it will write a result A. Here, it will do some A over here. Is it clear? So that particular thing only here, it will be going to update. So this can be called it as another type of a schedule. The next type of a schedule, it is does not preserve the value of A and B. It is a concurrent schedule, but it does not preserve. Why I am saying is it will read A. I doesn't write it over here. Again, it will read A. It is the original data, read it over here. It is not a debited data. Only it will shows the original data. So this is also, it can be an inconsistent. It is not preserve the value of A and B. Okay, so these are the another type of a schedule present in the database management system. Here I have given so much questions, basic questions of interview point of view questions. So according to this first 6 lecture series, I'm going to discuss about the transaction asset properties along with the schedules. In my upcoming session, we're going to see about the serializability. That is nothing but different process operated on how the different process can be operated on the shared data, how the each transaction preserve the data consistency. What do you mean by serial execution? That is a set of transaction preserve, how it can preserve the data consistency. So this can be notified by using a two different type. One is a conflict serializability and view serializability. That's all about the basic concept about the transaction. In next video, we're going to see my serializability concept. Thank you for watching my video.